Hello students and welcome to the lesson on trigonometric ratios of any angle. And this lesson is basically about taking the ideas that we're all familiar with from geometry and expanding on them into the world of trigonometry and seeing some of the advantages of this. And we won't see the full advantage of this until a couple lessons later when we talk about functions of trigonometry. But let's start, and this is hopefully mostly review for everybody. The definition of an angle in geometry is two rays with a common endpoint or a vertex. Two rays with a common vertex, and that's also called an endpoint. So in other words, we have an angle like this, has a common vertex or endpoint right here. This is angle x, or we'll call that x degrees. And what we learned from geometry is that x is somewhere between 0 and 360 degrees. It's probably more common for x to be between 0 and 180. But this is also true in geometry, that x can't be a negative number, x can't be over 360 degrees. Now let's expand on this idea and look at the definition of an angle for trigonometry. An angle for trigonometry. So the definition of an angle for trigonometry, and I'm going to write this a little bit in layman's term and a little bit in technical terms, is that the measure of how much a segment or ray has rotated. And in trigonometry, it's actually more common for us to work with segments than it is for us to work with a ray. So for example, we'll look at an example here. If I have an xy coordinate plane, I have a segment right here along the positive x-axis, and if I rotate it this way about 40 degrees, so we can say that this is angle theta, and that theta has a measure of 40 degrees. Or I can also say that I take the same thing, the same length here, and I spin it around once, that's 360 degrees, and I spin it around a little bit more. And so I've gone 360 degrees. So theta is equal to 360 degrees plus another 40 degrees. I can say that theta is equal to 400 degrees. And you see here the expansion, or the more general definition of an angle, is how much it's spun, and theta is this angle here, which is, it includes how much this has wrapped around. Okay. And as a convention, we say that anything that's rotated counterclockwise is a positive angle. Okay. Anything that rotates clockwise is a negative angle. So positive angle and negative angle. Now, because this definition involves us rotating and spinning things around, we have to define some of the sides, the initial side and the terminal side. And so the definition of the initial side is the starting point, or the starting point of the segment's rotation. And again, I'm doing this in somewhat of a layman's term so we can understand what's going on. If I show you the example, it'll be much more clear. And the terminal side is where the rotation stops. Where the rotation stops. For example, if I have a length here, and I'll make this a little bit bigger, this is this length right here, this is the initial side. Okay. That's the initial side. And if I take that angle and I rotate it, let's say I rotate it all the way over here, this is some theta. Well, now I have, this is the terminal side. or where it terminates, where the rotation terminates or where it ends, okay? And that's just a definition, and so it helps us to sort of better visualize the angle, because this isn't really a ray, or does it have to be two rays anymore? It can be a segment as well, and it's not defined in terms of how wide the angle is. It's more determined in terms of how much rotation has occurred. Okay, so what we've learned up to this point is that an angle is defined as how much it rotates. Now, if I have two angles and they rotate a different number of degrees, it is still possible for them to end up at the same spot. So let's see what happens in this scenario, and I'm going to show you an example before we define coterminal angles. So let's look at this example. If I have an angle and I rotate it this much, let's just for the sake of the argument say that this is 50 degrees. Okay, so that's an angle here, that's 50 degrees. Now I take another angle and I'll start it almost at the same spot, and I'll go clockwise this time. I'll go clockwise this far, and we'll say that this is negative 310 degrees. And I'll use the red here to illustrate. Okay. And so you can see from the picture that the red angle and the green angle are the same thing. They are congruent in geometric terms, but in trigonometry terms, they actually have different angle measures, even though they start and they end at the same spots. So that's what a coterminal angle means, is that we're saying that they are two or more angles that start or that have the same initial and terminal sides. Okay. So these two angles here, the blue and the red, they have the same initial side, and once they're done rotating, even though they rotate a different number of degrees, they rotate in a different direction, they both end up at the same spot. Okay. And at this point here, I need to make a clarification about standard position, because the initial side, it can be wherever we want, but the standard is to always make the initial side the x-axis. So the initial side is more often than not the positive x-axis. So sometimes we'll say, let's start over on the left side and rotate it, up here, down here, and rotate it. It's all okay. But the standard, and what that means is that if you don't hear anything, or if you don't see any specification about where to start, just start at the positive x-axis and you will be okay. So now let's take a couple examples and explore the idea of trigonometric angles a little bit further. It says here to find coterminal angles. Let's find two of them, one positive and one negative. For the first one here, for 45 degrees. To approach this problem, just start by drawing the angle, and that usually helps. So if you start here, 45 degrees is approximately here. And now we need to draw another angle that has the same terminal side, but has been rotated a different number of degrees. So one thing that I could do is just rotate all the way around once. That's 360 degrees, and then a little bit more. So this is 360 plus 45 degrees. So that's 405 degrees. Okay. And that's one of my answers. That's one of the positive answers, 405 degrees. And I need to look for another angle that, again, ends up here but is rotated in the negative direction. So one thing that I could do is take the start, the initial side, go around this way, and this would give, if I go around negative 315 degrees, that'll also give me a coterminal angle, so negative 315 degrees. And a good way to look at this is if you want a positive coterminal angle, you just keep on adding 360 degrees. So to find a positive coterminal angle, add 360 degrees repeatedly, as often as you can. Okay, repeatedly, until you get something positive. And to find a negative, coterminal angle, just subtract 360 degrees repeatedly until you get a negative number. Repeatedly. Okay. Now the same thing applies for when we're dealing with angles that are in radian. So if I have an angle that is pi over 9 radian, and because this is in radian, I think about it in terms of how many radians is a full circle. Well, that's 2 pi. So if I want a positive angle, instead of adding 360 degrees, I need to add 2 pi. So for this problem, pi over 9, just add 2 pi to it. This will give me pi over 9 plus 18 pi over 9, and that gives me 19 pi over 9. Same scenario, similar scenario, if I want to get a negative angle, instead of adding 2 pi, I subtract 2 pi repeatedly. So in our problem from before, if I want a negative coterminal angle, pi over 9, I subtract 2 pi from that. And this will give me pi over 9 minus 18 pi over 9, which will give me negative 17 pi over 9. And if you draw out these pictures, you will be able to see that 19 pi over 9, negative 17 pi over 9, pi over 9, all end up at the same point when you rotate it from the positive x-axis. Okay. Let's look at one last example when we start already with a negative angle. So we have one final example here of an angle that's negative 372 degrees, and I want to find an angle, a coterminal angle that is positive and negative. And I'll follow my rule here to find a positive angle in degrees. We'll just add 360 degrees. So if I add this 360 degrees, this will give me negative 12 degrees. And this is coterminal, but it's not a positive one, so I just add it again. And now I'll get 348 degrees, and this angle is in fact coterminal with negative 372 degrees. And so I can stop there. So this is what the repeatedly really means. It's just if you don't get a positive number or a number that you're looking for, just add 360 degrees again. Now for the negative one, we'll just negative 372 minus 360 degrees. And in this case, it's in fact going to give us a negative number. It's going to give us 732 degrees, negative 732 degrees. It's negative, satisfies what we're looking for, and so we can say that we're done. And so this is a brief introduction into the world of angles when we're talking about trigonometry, where it's not, the angles are no longer limited to 0 and 360 degrees. The angles could be anything that is a real number between, of course, negative infinity and positive infinity. I'm going to end this video right here and continue the lesson on another video as we sort of transition into a more interesting and more challenging concept.